So this lecture, this article is inspired by the previous lecture. They just used the forest instead of a tree. So it is done by great people in Monash University. So let me explain this article. Incorporating syntactic uncertainty in neural machine translation with forest to sequence model, not tree to sequence model. The previous lecture was tree to sequence model, now forest to sequence model. So our motivation is that it is good for low resource language pairs. Incorporating syntactic information in neural machine translation models is a method to compensate the requirement for a large amount of parallel training text, especially for low resource language pairs. So our forest, it means exponentially many parse trees. And we propose a forest to sequence attentional neural machine translation model to make use of exponentially many parse trees of the source sentence to compensate for the parse errors. Our method represents the collection of parse trees as a packed forest and learns a neural attentional transduction model from forest to the target sentence. Another motivation is that it's good for distant language pairs. For example, in English to Farsi, English to Persian. It is expected that modeling these hierarchies, syntactic trees, will improve the performance of neural machine translation model, especially for linguistically distant language pairs like English to Farsi, or English to Japanese was distant as well, as I've mentioned in the previous lecture. So compact forest instead of just single one best tree. If you remember the previous lecture, we picked a single best tree, but now we have a compact forest. So a tree to sequence model uses one best parse tree generated by the parser, and mistakes and uncertainty in parsing eventually affect the performance of translation. In this section, we propose a novel ANMT model, which utilizes forest of trees. Forest to sequence model computes embeddings of phrases using a bottom-up fashion based on exponentially many trees. And so this is your architecture. You can generate a phrase from two completely different parse trees. You can take Saw and Jane and take this, or you could take Jane with May, with and telescope. So there are different ambiguities could arise. And the model for forest LSTM combines a phrase embedding results of multiple trees. So N here is the number of children, because we are combining them. For example, if a constituent has three, if you have three constituents, N is 3 in this case. So it's just N is just a number of children. So everything is like before, but NP is now bigger because it's a number of different phrases in the forest. So the same architecture that I explained in the previous lecture, but with higher N number of phrases. You see, the forest to sequence has lower perplexity. If you have seen my playlist for language modeling, perplexity is a measure in language modeling. We use it. Here we use it as well. And For tree, they have compared it with tree to sequence, this paper with this Japanese university. I explained it this in the previous lecture. And the vanilla machine translation. That this is an alternative to, of course, to the first lecture. And for English to Farsi, we will see that their BLEU measure is 12, and for forest to sequence it is 11. But their tree to sequence is even worse. So it's a slight improvement. Perplexity is almost the same.